Good morning. Today we are going to finish up solving our systems of 3 by 3 equations, so 3 equations and 3 unknowns. We are going to be using page N22 in the notes and also page N23. We're going to start actually on page N23 just to review a bit of what we did yesterday. We're going to start here at number 1. We have 4x minus 3y plus 5z is negative 19. 3x minus y equals 8z minus 21. And y equals 2x minus 3z plus 13. Now, one thing that's different from today than yesterday is yesterday when we started, we had all of our variables all stacked on top of each other and lined up. We don't have that today, so the first thing that we're going to need to do is to rewrite this so that our variables are stacked up. Now, this first equation is fine because it's x, y, and z, so I'm just going to write that right over here. 4x minus 3y plus 5z is negative 19. Then on this one, this second one, we have to take this 8z and move it to the left. When we move it to the left, it'll become a minus 8z. So we have 3x minus y minus 8z equals negative 21. Don't lose that negative sign with the 21. And then on this third one, we actually have to move the 2x and the 3z. So we move that 2x over. That'll be a negative 2x plus the y. And then add that 3z over. So plus 3z is, and then positive 13. There's your equations A, B, and C. Now the variables are all stacked up. Let's go ahead and decide what variable we want to eliminate. Again, you can choose any variable you want to eliminate. I tend to look for one that I only have to, one that I don't have to multiply any equations by anything, or I only have to multiply one equation by something. And I see pretty easily right here between equation B and C, we could eliminate out the y. Let's go with that. So let's do equation B and equation C to eliminate the y. Equation B, 3x minus y minus an 8z is negative 21, and a negative 2x plus a y plus a 3z equals 13. Okay, the y's eliminate here, and we are left with 3x minus 2x, or x, minus a 5z equals a negative 21, and 13 is negative 8. All right, that created another equation for us that created equation D with just x's and z's. All right, let's go back and let's look again and try and eliminate the y from 2 other equations. I think I'm going to go with A and C. Since they are opposite signs, I could just multiply this C by a positive 3. So if I multiply that equation C by a positive 3, equation A stays the same. 4x minus 3y plus a 5z is negative 19. Equation C, multiply that by 3, that gives us a negative 6x plus a 3y plus a 9z equals 39. Add those guys together, and again, the y's eliminate, and we have a negative 2x plus 9 and 5, 14z is 20. That created yet another equation, call it E. All right, now look at these 2 equations. These are 2 equations with x's and z's, and let's go ahead and try and eliminate out one of those. Let's see, I think it would be easiest to eliminate out the x because we could multiply this equation over here by a 2. So let's go to eliminate the x. And to do that, we'll multiply this equation here by a 2. And we're using equation D and E. Multiply this one by a 2. That gives us 2x minus a 10z equals a negative 16. And keeping this one the same, negative 2x plus a 14z equals 20. That eliminated out the x's, and we're left with 4z equals 4, which means z is 1. There's one answer right there. Now we have to go back and we got to find out what y and x are. And basically you go back up the steps. So here's where we found out z. So we'll go back up one layer, and you have to go into one of these equations right here to figure out the z. I think I'm going to use equation D. So I'm going to figure out what z is. I'm going to go into x minus 5 times 1 minus an 8, equals negative 8, my mistake, I'm sorry. And that gives us x minus 5 is negative 8. Add that 5 over, that means x is negative 3. There's that one. Now we have x and z, and we were here to find z. Go up one layer to find x. Now you got to go back one more layer, back to the original, to figure out what y is. And actually, I think I would go back right here to this one, right in the beginning, where it's solved for y already. So this says y equals 2x, 2 times a negative 3, minus 3 times z, 1, plus a 13. That's negative 6 minus 3 plus 13. Negative 6 minus 3 is negative 9, plus 13, 4. And there we go. Almost. Final answer is actually, it's not an ordered pair, it's an ordered triple, x, y, z. So negative 3, 4, and 1, x, y, z. That's the final answer. There we go. Okay, now, so that finished up page, or that did one problem on page N23. I wanted to refresh your memory from yesterday. Let's go ahead back now to page N22. This is page, I'm going to try and focus that, because to me it doesn't look in focus. Let me put this one here. Okay, hopefully that's a little bit better. I think it looks better. All right, we're going back to page N22. Here it is, N22. And we're going to start right up here with solving this system. Now these two do something weird, so I wanted to make sure I did just a regular one for you first, and then we can handle these weird ones. All right, we see right off the bat that our variables are stacked, x, y, and z, so we're good to go there. Let's go ahead and think about eliminating out a variable. And again, really you can choose any of them, but I see, since the y's are opposite signs here, that I could go ahead and eliminate out that y pretty quickly. And to start, if I use equations A and C, so x plus y minus z is 2. 2x minus y plus 4z is 7. And right off the bat, these y's subtract out, and we'll get 3x plus 3z is 9. That created our fourth equation, D. We still need to eliminate out a y. I already did it from A and C, so two different pair of equations. How about we use B and C? B, 3x plus 3y minus 3z is 8. And C, What if I multiply that one by, say, a 3? That'll give us 6x minus 3y plus 12z is 21. Now if we look, the y's subtract out, and we have 9x plus 9z equals 29. There's our fifth equation, E. And again, now we are down to a system of 2 equations and 2 unknowns. We have x's and z's, so let's eliminate out either the x's or the z's. I think either way we're going to have to multiply this equation over here, D, by negative 3. And we're going to use equation D and E. Let's multiply this equation by a negative 3, so that D is going to become negative 9x minus 9z is negative 27. Leaving E alone, 9x plus 9z equals 29. Combining those two, oh boy, look what happens here. The x's divide out, or subtract out, I'm sorry, the z's subtract out, and the left side we're left with 0. And on the right side we're left with a 2. Can 0 equal 2? No. So what that's telling you is, from way back when, a couple of weeks ago, there is no solution to this problem. If all of your variables subtract out and you get a false statement, then there is no solution to this problem. That's your answer. Okay. All right, let's take a look at this one down here. And let's solve this system. Again, let's try to eliminate out a variable here. Oh, you know what? Let's change things up this time. Let's eliminate out an x. So, if I want to eliminate out an x, let's again use A and B. You do not have to eliminate out the x. You could eliminate out a z, or you could eliminate out a y. I just opted to eliminate out the x to do something different. So we weren't always eliminating out a y. And in order to eliminate out that x, we're probably going to have to multiply one of these equations up here by a negative 1. Let's do this one by a negative 1. A will stay the same then, at x plus y plus z is 6. B becomes negative x plus y minus z equals negative 6. When we combine these terms here, we'll get x and negative x. Oh, those guys subtract out. The y's becomes a 2y. The z's subtract out, and we get 2y is 0. Now, that's not an empty set. That's 2y equals 0. Divide both sides by 2, and you'll get y is 0. There's a solution right off the bat. There's one of them. All right, now, even though we have y is 0, we still need to go back to where we were. We were trying to eliminate out an x. So let's come back over here, and let's try to eliminate out an x. That was equation D over here. Let's go with, what if we multiplied this one up here, this b, by, instead of just by a negative 1, what if we multiplied that by a negative 4? Then our equations B and C would be a negative 4x plus 4y minus 4z equals a negative 24. Negative 4x plus 4, yep. Let's do this one down here. So 4x plus y plus 4z is positive 24. When we combine like terms here, x's divide out, or subtract out, z subtract out, we get 5y equals 0. Uh-oh, y is 0. Oh boy. So we just got the same solution here. That's not good, because eliminating out the x didn't help us very much. Oh, bummer. So that means that we're going to have to go back and we're going to have to eliminate out a different variable. Oh, man. I know it's frustrating, and I know it's sad, but we still have to do it. So let's go back to probably where we should have started, and let's eliminate out a y. All right, so if we go back to eliminate out a y, I'm just going to cover this up because we're not using that anymore. We can add a and b. Eliminating out that y then gives us 2x plus 2z equals 12. Let's call this one, I'm going to take that d away and call this a d down here. All right, let's go back, and we also need to eliminate out a y from two different ones. So we did a and b. What if we now do b and c? Because then I don't have to change any signs at all. b, c. So b is x minus y plus z is 6. And c, 4x plus y plus 4z is 24. Y's subtract out, and we have 5x plus 5z is 30. All right, so here's our new equations. Now, phew, we're doing good because now we have two equations with x's and z's. We need to combine these and make one of those variables eliminate out. When we multiply here, what if we did negative 5 times d and 2 times e? So negative 10x minus 10z equals negative 60. And 2 times this one, let's see, that could be 10x plus 10z equals positive 60. Uh-oh, what happens? Everything subtracts out, and we get 0 on the left equals 0 on the right. What does that mean? Does 0 equal 0? Yes, it does. This is a true statement. So your answer is infinitely many solutions. There are infinitely many solutions for this one. So that's why these two came up kind of weird. One of them came up as an empty set, and one of them came up as infinitely many solutions. And I wanted to show you just a regular one first before we came up with these weirdo ones. All right, last one for today. We are going to look at this word problem. Now notice here, it just says set up a 3x3 system. set up a 3x3 system. It doesn't say solve. So you don't have to solve it. You just have to set it up. All right, so here's what we have. At a carry-out pizza restaurant, an order of 3 slices of pizza, 4 breadsticks, and 2 juice drinks costs $13.35. A second order, 5 slices of pizza, 2 breadsticks, and 3 juice drinks costs $19.50. 4 breadsticks and a juice drink cost 30 cents more than a slice of pizza. What's the cost of each item? Oh my goodness. Is your head spinning? Don't let it spin. It's not that bad, really. All right, sometimes what I want to do here is use the first letter to represent the variables. So pizza, let's go with P. Breadsticks, we'll go with B. And let's use J for juice boxes. So if we set this up, we have 3 slices of pizza, so 3P, plus 4 breadsticks, 4B, and 2 juice drinks, 2 juice drinks, is, or costs, $13.35. There's one equation. A second order of 5 slices of pizza, 5P, plus 2 breadsticks, 2B, and 3 juice drinks, 3J, that costs $19.50. Now notice in here, when I wrote these equations, kind of where the cost was, that's like the equal sign. 3 pizzas, 4 breadsticks, 2 juice, costs $13.35. 5 pizza, 2 breadsticks, 3 juice, costs $19.50. That idea can help you do this next equation, that cost is going to be like the equal sign. So here we go for this last one. 4 breadsticks, and a juice drink, plus 1 juice drink, cost equals 30 cents. Don't forget the decimal here, 0.30, more than, plus a slice of pizza, P. There we go. That's the setup. I'm not asking you to solve that. Just set that up. Sometimes you have to solve them if it says set up and solve, but this one just said set up, so that's all we have to do. Okay, don't close up yet. Thank you very much for your attention through this video. I really appreciate it. Your homework, trying to find it. Oh, I wrote it somewhere. Hold on. Your homework for today is on pages, gotta find it, H25 and H26. Questions 1 and 6. And finish page H25 to H26 nope, it wasn't 1 and 6, I'm sorry, this was 2 and 6. 2 and 6. And we did one together yesterday, so I need you to do questions, if you didn't finish them for yesterday, or for today, 3, 4, 5. Okay? So 1 we did yesterday in class together, I believe, and then I want you to finish page H25, H26, 3, 4, 5. Oh, let's just throw this in there in case you didn't do it. 1. Then that whole worksheet will be done. Thank you very much again for your attention. I'm sorry about the confusion at the end. I hope you have it. Have a nice weekend, and I'll see you Wednesday, because it's a long weekend. Thank you. Bye now.